Hello friends, welcome to H2 Advent Academy. In the last lecture we have discussed up to question number 25. So we will discuss question number 26 onwards in this particular lecture. So basically we are discussing the problems on the Gauss divergence theorem. So let's start our discussion. So what is given in question number 26? So we have the value of f is equal to x I cap minus y j cap plus z square minus 1 k cap, and we have to evaluate the value of surface integral f dot n cap ds, and using Gauss divergence theorem this is equal to volume integral divergence of f dv. Okay, and S is a closed surface bounded by the planes z is equal to 0, z is equal to 1 and cylinder. So let us draw the cylinder. This is our cylinder. Okay, and this is our axis. This is x axis, this is y axis, and this is sorry this is z axis. Okay, so let us evaluate divergence of f first. So divergence of f is equal to del upon del x of x plus del upon del y of minus y plus del upon del z of z square minus 1. So this is equal to 1 minus 1 plus 2z. So this is equal to 2z. So divergence of f is equal to 2z. So we have f dot n cap ds surface integral. Let us take this as I. The value of I is equal to divergence of f dv. So this means this is 2z. This means this is 2z into dv. dv we can write as dx, dy and dz. Okay, so this is volume integral. So we have the transformation from Cartesian coordinates to the cylindrical coordinate system. Okay, so because this is a cylinder, so we can use the polar coordinates here. Polar coordinates. Okay, so we have under polar coordinates we have spherical coordinate system and cylindrical coordinate system. So based on the demand of this question, we will use cylindrical coordinate system. Okay, so any point on this any point under this cylinder can be represented as r, theta and z. So we have the transformation from Cartesian coordinate x, y, z to r, theta and z, and the differential transformation under the differential dx, dy and dz is being transformed to dr, r d theta and dz. Okay, so the product of dx, dy and dz will be r dr d theta dz. Okay, and z will remain same. So we have this as triple integral 2z. This is r dr d theta dz. Okay, so this planar region will look like something like this. Okay, so this is of radius 2 unit. Okay, so let us take an elemental. Let us take an elemental area dA at an angle of theta. So this will be d theta, and this distance is r. So this distance will be dr, and this is r d theta. Okay, so this is the elemental area, that is dA. So dA will be equal to dr into r d theta. Okay, so the limits on the limits will be, let us write down the limits. So r limit, theta limit and z limit. So the radius of this planar region is 2. So r varies from 0 to 2, because equation of this is x square plus y square is equal to 4, that is 2 square. So r varies from 0 to 2 and theta varies from, so this whole region will get transferred once we vary theta from 0 to 2 pi. So theta varies from 0 to 2 pi and z varies from, so this is the z limit. So this surface area is being bounded by the plane. This is z is equal to 0 and this is z is equal to 1. So z varies from 0 to 1. So r limit, r is equal to 0 to 2 and theta is equal to 0 to 2 pi and z is equal to 0 to 1. So this is the value of I. So let us integrate this for getting the desired result. Okay, let us simplify this further. Okay, so we have the value of I as, so this is 2z and this is z. So z dz, this means 2 times of z square upon 2. And limit is 0 to 1 on z limit. And this is r dr, so this is r square upon 2. And limit on this is 0 and 2. And at last we have d theta. So integration of d theta is theta. The limit is 0 to 2 pi. So this is equal to I is equal to 2 times of 1 upon 2 into 2 square upon 2. This is 2 square upon 2. This means 2 into 2 pi. This gets cancelled. So this is equal to 4 pi. So the value of integral I, that is surface integral f dot n cap ds, is equal to 4 pi. Okay. Let us discuss question number 27. How we can solve this? Okay, so we have to find the value of a dot n cap ds, surface integral. Okay, so using Gauss divergence theorem, this is equal to divergence of a dv. Okay, volume integral. So let us find the divergence of a. So this is equal to I, j and k. Sorry. This is not curl of a, this is divergence of a. So divergence of a is equal to del upon del x of 2x plus 3z plus del upon del y of minus xz minus y. This is minus xz minus y plus del upon del z of del upon del z of y square plus 2z. So this is equal to 2. This is minus 1 and this is plus 2. This is equal to 3. Divergence of a. Okay, from here it is 2. This is minus 1. 2 minus 1 is 1. And here it is 2. This is 3 units. So from Gauss divergence theorem, a dot n cap ds surface integral is equal to divergence of a dv, triple integration. Okay, so we have the value of I as, let us take this as I. So we have the value of I as triple integration 3 times of dv. So this is equal to 3 times of volume integral dv. This is equal to 3 times of volume v. So S is the surface of a sphere having center at, the F is the, sorry, S is the surface of a sphere at having center 3, minus 1 and 2 and radius is 3. Okay, so this surface S is enclosing a volume V. So we have to calculate this volume V. So V is equal to 4 by 3 pi into radius. So radius is 3 cube. This is equal to 4 pi into 3 square. Okay, so we have the value of I as I is equal to 3 times of, let us put here. So 3 times of 4 pi into 3 square. 27. This is 27 into 4. This is equal to 108 pi is the answer. Let us discuss question number 28. How we can solve this? So we have applied divergence theorem to evaluate this. Okay. So using Gauss divergence theorem, so we have the expression as f dot n cap ds surface integral is equal to divergence of f dv along the volume v. So based on this particular expression, we have, on comparing this with this one, f dot n cap ds, the value of f will be f is equal to x plus z I cap plus y plus z j cap plus x plus y k cap. Okay, so from here we have the divergence of f is equal to del upon del x of x plus z plus del upon del y of y plus z plus del upon del z of x plus y. Okay, so this is equal to 1 plus 1, that is 2. This is equal to 2 times of dv, surface integral, sorry, volume integral. So this is equal to 2v. So S is the surface of a sphere having center 0, 0, 0 and radius is 2 unit. So we have this as 2 times of the volume will be 4 by 3 pi into 2 cube. Okay, so this is equal to 8 into 8. This is 8, 64 pi upon 3 is the answer. Let us discuss question number 29. How we can solve this? See, S is a closed surface enclosing a volume V. S is a closed surface that is enclosing a volume V, and the value of F is equal to x I cap plus 2y j cap plus 3z k cap. Okay, so we have to prove that the value of I as surface integral f dot n cap ds is equal to 6v. This we have to prove. So we have, using Gauss divergence theorem, f dot n cap ds along the surfaces is equal to triple integration divergence of f dv. Okay, so the divergence of f divergence of f will be del upon del x of x plus del upon del y of, let us write down the components. This is x, this is 2y, del upon del y of 2y plus del upon del z of, this is 3z. So this is equal to 1 plus 2 plus 3. This is equal to 6. Let us place here. So this is triple integration. This is 6 times divergence of f is 6. This is 6 dv. So this is 6 equal to 6 triple integration dv. So this is equal to 6v. Let us discuss question number 30. Okay. So we have to evaluate this one, where S is the part of a sphere above xy plane and bounded by this plane. Okay. So we have the surface of a sphere like this. This is our S is the part of a sphere above xy plane and bounded by this plane. So this whole is the surface area. This is curved surface plus bottom surface constitutes the value of S. So this is our surface area. Okay. So the equation of a sphere is x square plus y square plus z square is equal to 1. Okay. So we have, using this particular expression, we can calculate that. So this is I is equal to surface integral y square z square I cap plus z square x square j cap plus z square y square k cap dot n cap ds. So using this we can say that f is equal to y square z square I cap plus z square x square j cap plus z square y square k cap. Okay. So from here we can say that f dot n cap ds surface integral is equal to divergence of f dv triple integration. Okay. So divergence of f will be, divergence of f is equal to del upon del x of y square z square plus del upon del y of z square x square plus del upon del z of z square y square. So this is 0 plus 0 plus this is 2zy square, divergence of f. So let us place here, this is 2zy square and dv we can write as dx dy dz. This is the value of I. So we have taken the value of this one as I. Okay, so I is equal to 2zy square dx dy dz. So let us use a spherical coordinate system here. Okay, so we have the sphere that is lying above xy plane. Okay, this is our axis, this is x, this is y and this is z. Okay, so the surface area of this sphere will constitute this curved surface plus this bottommost planar surface. So this whole surface area S is equal to curved plus planar surface area constitutes the S. So let us apply the spherical coordinate system here. So any point here will be represented in terms of r, theta and phi. Okay, so r here varies from 0 to 1. Okay, this is theta and this is the projection of this on xy plane will be at this particular point. So let us join this. This particular angle is phi. Okay, so like this, this is xy plane, so this is theta and projection of this is xy plane is like this. So this is r, so this is r sin theta and this whole angle is phi. The value of x will be, this is phi, so this is x is equal to r sin theta cos phi. Similarly this is y, this value is, this is y, so y is equal to, this is phi, so this is 90 minus phi, so y is equal to r sin theta sin phi. Okay, and z will be, z is equal to r cos theta. So we have x is equal to r sin theta cos phi, y is equal to r sin theta sin phi and z is equal to r cos theta. Okay, let us write down the limits here. So we have the limits as, so the limit on theta will be, theta varies from 0 to pi by 2 because this surface is lying above xy plane. So theta will varies from 0 to pi by 2 only. This is pi by 2. So theta varies from 0 to pi by 2. R varies from 0 to 1 because the radius is 1, and phi varies from, so this phi is lying in xy plane. So for covering the whole region, this phi has to be taken throughout the 360 degree, that is theta phi varies from 0 to 2 pi because this has to cover the whole planar region on the xy plane. So this phi varies from 0 to 2 pi. So these are the limits. So let us place the limits on this. Okay, so let us further simplify this. So we have I as 2 times of z times of y square. The value of z is r cos theta. So this is r cos theta into y square. Value of y is r sin theta sin phi whole square into dx dy dz. So we have the transformation is x y z is getting transformed to r theta and phi, and dx dy dz is getting transformed to dr, different and change in theta, r d theta. Okay, and this is r sin theta d phi. Okay, so this is the differential along the theta cap direction. This is the differential along r cap direction. This is differential along the phi cap direction. Okay, so this will, the product will be, product of dx dy dz will be r square sin theta dr d theta d phi. Okay, let us place the limits here. So I is equal to 2 times of, let us place the limit, r is equal to 0 to 1, this one. Theta varies from, theta is equal to 0 to pi by 2 because this is above xy plane. This is pi by 2, 0 to pi by 2, and phi varies from 0 to 2 pi because we have to cover the whole planar region because phi lies in the phi is lying in xy plane. Okay, so now let us integrate this for getting the answer. Okay, so we have the I as r is 0 to 1. So we have this as, here r square is there, here r square is there, and 1 r is there. So this is r to the power 4 and this is r5. So the r5 dr will be r6 upon 6. So 2 times of r6 upon 6. Limit is 0 to 1. So now we have this as theta. So this is sin square theta and this is sin theta. So this is sin cube theta cos theta. Okay, and we have sin square phi. This is d theta and d phi, d theta and d phi. So we have the limits as theta is equal to 0 to pi by 2 and phi is equal to 0 to 2 pi. Okay, so we have this as 1 upon 3 times of. Okay, so we have the value of integral sin cube theta cos theta d theta 0 to pi by 2. Okay, so let us take sin theta as t. So we have cos theta d theta is equal to dt. This is t to the power cube dt. Okay, and let us change the limit. So when theta is equal to 0, t is equal to, when theta is equal to 0, t is equal to 0, and when theta is equal to pi by 2, t is equal to 1. So t is equal to 0 to 1. So this is equal to t4 upon 4. Limit is 1 comma 0. Sorry, limit is 0 to 1. So this is 1 upon 4. The value of integral sin cube theta cos theta is 1 upon 4. So the value of this is 1 upon 3 because r6 upon 6, the limit is 0 to 1. So this is 1 upon 6, 1 upon 3. And the value of this one sin cube theta cos theta d theta 0 to pi by 2 is 1 upon 4, because we have calculated t4 upon 4, limit is 0 to 1. Okay. So we have calculated now, this is sine cube theta cos theta d theta 0 to pi by 2. Okay, so we have taken sine theta as t, so cos theta to theta is dt. So this is t cube dt. So t4 upon 4, the limit is 0 to 1. This is 1 upon 4. So now we are left with 0 to 2 pi sine square phi d phi. Okay, so we can multiply with 4 and divide by 4. So this gets cancelled. This is 1 upon 3 into sine square phi 0 to pi by 2 sine square phi d phi. This is the value of I. So I is equal to 1 upon 3 into 1 upon 2 into, this is being integrated by sine rule. So this is 1 upon 2 into pi upon 2. So this is equal to pi upon 12. Pi upon 12 is the answer. Let us discuss question number 31. Okay, how we can solve this? By converting the surface integral into volume integral, evaluate this. So on comparing this with Gauss divergence theorem, so we have the value of f as f is equal to x cube I cap plus y cube j cap plus 3z square, sorry, this is z cube. This is z cube k cap. So from here divergence of f is equal to 3x square plus 3y square plus 3z square. Okay, so from Gauss divergence theorem, f dot n cap ds surface integral is equal to triple integration divergence of f dv. Okay, so divergence of f we have calculated as this one. So let us take this as I. So the value of I is equal to triple integration. This is 3 times of x square plus y square plus z square. This is dx dy dz. dv we can write as dx dy dz. So s is the surface of a sphere, that is x square plus y square plus z square is equal to 1. Okay, so let us take any point here. So any point we can represent as r theta and phi. R theta and phi. So r varies from 0 to 1. Theta varies from 0 to, because we have taken theta like this. So theta has to go, okay, see theta varies from 0 to pi. Okay, and phi is lying in the xy plane. So phi varies from, this is 0 to pi. Theta varies from 0 to pi. This we have discussed in polar coordinates. Okay, and phi varies from 0 to 2 pi. Okay. So this whole region, this whole volume will get covered when we vary theta from 0 to pi. We have not to vary theta from 0 to 2 pi. Okay, so it will double the volume. Only we have to vary theta from 0 to pi only, and phi varies from 0 to 2 pi. Let us place the limit here. So I is equal to, and we have the value of this will x square plus y square plus z square is equal to r square. And we have dx dy dz in terms of a spherical coordinate as r square sine theta dr d theta d phi. So we have 3r square, this is r square sine theta dr d theta d phi. Okay, so the limits are r is equal to 0 to 1 and theta is equal to 0 to pi and phi is equal to 0 to 2 pi. Okay, so let us place the value here. So I is equal to, this is 3 times of, this is r square, this is r to the power 4. So this is r5 upon 5, r5 upon 5, limit is 0 to 1, and we have this as sine theta d theta. So this is minus cos theta. Minus cos theta, limit on theta is 0 to pi. Okay, and we have The integration of d phi is phi. So phi limit is 0 to 2 pi. So this is equal to I is equal to 3 upon 5 into on placing the limit, the value of this will 2. Cos of pi is minus 1 and cos of 0 is 1. So this is 1 minus of minus 0. Sorry, this is minus of cos pi is minus 1 minus and cos of 0 is 1. So this is equal to 2 times of 2 pi. So this is I is equal to 12 pi upon 5. Okay, now let us discuss question number 32. How we can solve this? So we have the value of f is given by this particular expression. Evaluate surface integral del cross f dot n cap into ds, where s is the surface of a sphere above xy plane. Okay, so this is a basically a tricky question. Okay, so we have the surface of a sphere that is lying above xy plane. So this is our xy plane, this is x and this is y, this is z. Okay, so this curved surface is given as surface S. Okay, so let us take the whole surface area, that is whole surface area is S dash. Okay, let us take whole surface area as S dash, that is whole surface area, whole surface area, whole surface area, that is whole surface area will constitute, whole surface area is curved surface plus bottom surface, bottom planar surface. Okay, so this is our bottom planar surface, this one. This is bottom planar surface and this is curved surface. So curved surface is S and bottom planar surface, let us take this as S1. So this is S1. So we have S dash is equal to S plus S1. Okay, so now let us apply the Gauss divergence theorem. So using Gauss divergence theorem, f dot n cap ds along the surface. So while applying the Gauss divergence theorem, we have to take a closed surface. So this surface area S dash will constitute a closed surface because we are taking the whole surface area. So this is S dash is equal to triple integration divergence of f dv. Now, so let us replace f with curl of f. Okay, let us replace f with curl of f. F, we are replacing f with curl of f. So this is equal to surface integral S dash curl of f dot n cap ds. This is equal to volume integral divergence of curl of f dv. Okay. Okay. So using vector identity, divergence of curl of f is equal to 0. So this is straight away 0. This means this is 0. So we have the value of s dash as s plus s1. So this we can expand as surface integral s curl of f dot n cap ds. So this s is curved surface. Okay, plus and surface s1. S1 is planar surface. Curl of f dot n cap ds is equal to 0. Okay, on this planar surface, the value of n cap will be minus k cap because the unit vector along the outward normal will be perpendicular to this, and this will be along the negative z direction. So this is minus k cap. Okay, so this n cap is minus k cap. Let us further simplify this. So we have um, curl of f dot n cap ds along the surface s, that is curved surface is plus, this is n cap is minus k cap, so this we can write as s1 curl of f minus k cap into ds is equal to 0. So this is equal to along the surface s curl of f dot n cap ds is the minus surface integral s1, that is planar surface, curl of f um, curl of f dot k cap into ds is equal to 0. So this means This means surface integral along the surfaces curl of f dot n cap ds is equal to along the surface S1, that is planar region, curl of f dot k cap ds. Okay, so let us calculate curl of f. So let us write down here. So we have this as surface integral curl of f dot n cap ds is equal to along the surface, that is planar surface S1, curl of f dot k cap ds. Okay, now let us further simplify this. Okay, so we have the curl of f as, so this is equal to I, j and k. This is del upon del x, this is del upon del y, this is del upon del z. And we have the components of del cross, curl of f is del cross f. The components of del is this one and component of f is this one. So this is x square plus y minus 4, this is 3xy, this is 2xz plus z square. So let us calculate this. So this is equal to I cap times of del upon del y of this one. So this is 0. This is del upon del z of 3xy minus 0 plus j cap. This is del upon del z of this one. This is 0 minus del upon del x of this is 2z. Okay, plus k cap. This is del upon del x of 3xy. This is 3y. And this is del upon del y. This is minus 1. So this is equal to minus 2z I cap plus 3y minus 1 k cap. Okay, so let us place the value of curl of f here. So we have the surface integral curl of f dot n cap ds is equal to along the surface S1. Curl of f is this one. So the dot product of k will result into 3y minus 1 only. So this is 3y minus 1 ds. So this is this surface S1 is a planar region. Okay, planar region with equation x square plus y square is equal to 4. This is a planar region. So this we can write as dx dy. Okay, let us convert this into polar coordinate. Okay, so using this x square plus y square is equal to 4, we can take x is equal to r cos theta, y is equal to r sin theta, and theta varies from 0 to 2 pi. Let us place the limit here. So this is equal to r varies from r is equal to 0 to 2, because the equation of this is radius is 2. So r varies from 0 to 2 and theta varies from 0 to 2 pi. And this is 3 times of the value of y is r sin theta. So this is 3r sin theta minus 1, and dx dy is because x and y is getting transformed to r theta, and dx dy is getting transformed to dr and r d theta. Okay, so this is dx dy is multiplication of these two. So this is r dr d theta. This is the value of I. So on integrating this, we will get the desired result. So let us integrate this. So I is equal to this is 3r sin theta and this is r square. So this is 3r square dr. 3r square dr. So this is 3r cube upon 3. Limit is 0 to 2 sin theta minus and this is r dr. This is r square upon 2. This is r square upon 2. Limit is 0 to 2. Sorry, the limit will be x square plus y square is equal to 4 square, no? So limit is 0 to 4. 0 to 4. Sorry. Because the radius is 4. Because the equation of a sphere is x square plus y square plus z square is equal to 16, that is 4 square. So the equation of planar region will be x square plus y square is equal to 4 square. So radius is 4. So r varies from 0 to 4. So limit will be 0 to 4. Okay. So 3 times of this is r square dr. So r cube upon 3. Okay. Minus this is r dr. So this is r square upon 2. So r square to limit is 0 to 4. And this is d theta. Theta is 0 to 2 pi. So I is equal to this gets cancelled. So this is equal to this is 64 sine theta minus this is 4 square upon 2. This is 16 upon 2, that is 8 d theta. This is 0 to 2 pi. Okay. So I is equal to 64 of the integration of sine theta is minus cos theta. Limit is 2 pi and 0 minus 8 times of integration of d theta is theta. Limit is 0 to 2 pi. So this gets cancelled because minus of limit cos 2 pi is 1 and cos 0 is also 1. So the 1 minus 1 is 0. So this is 8 times of minus 8 times of 2 pi. So this is 16 pi minus 16 pi. I is equal to minus 16 pi. Answer. Let us discuss question number 33. How we can solve this? So we have similarly based on the previous result. So let us plot this cone. So we have the evaluate del cross A dot n cap ds. This we have to evaluate along the surface S. Okay, and S is the surface of cone. So the equation of cone is z is equal to 2 minus root under x square plus y square. Okay, so let us place 0 here. Z is equal to 0. When we place z is equal to 0, this is x square plus y square under it is equal to 2. This means x square plus y square is equal to 4. Okay, so our cone will look like this one. And this is the axis. This is x, this is y, and this is z. Okay, so S is the surface of the cone. So this curved surface is S. Let us take the planar surface as S1 and this whole surface as S dash. So S dash is equal to S dash is complete surface area, whole surface area is equal to curved surface area plus planar surface. This is curved and this is planar. This is bottommost surface. So S dash is equal to S plus S1. So using Gauss divergence theorem, we have along the surface S dash f dot n cap ds is equal to divergence of f dv, volume integral. Okay, and s dash is equal to s plus s1. Okay, so let us place here, let us replace f with curl of f, curl of a. Let us replace this. So curl of a dot n cap ds along the surface s dash is equal to divergence of curl of a dv, volume integral. So using vector identity, divergence of curl of a is 0. This is straight away 0. So this we can expand as s dash is s plus s1. So this is equal to surface integral s curl of a dot n cap ds plus surface integral s1, that is planar surface, curl of a dot on planar surface. The value of n cap will be, because this is a planar surface, so outward normal will be along negative z direction, that is minus k cap. So this is minus k cap into ds is equal to 0. So this means surface integral curl of a dot n cap ds is equal to surface integral s1, that is planar region, curl of a dot k cap into ds. Okay, so let us find curl of a. Okay, and we take the dot product with k cap. So curl of A will be, this is I, this is J, and this is K. So the components of this is del cross A. So components of del operator is del upon del x, del upon del y, and this is del upon del z. And component of A vector is x minus z, x cube plus yz. This is minus 3xy square. Okay. So this is equal to I cap. This is, let us take cross product del upon del y of this one. So this is minus 6xy. And this is del upon del z. So this is minus y plus j cap. This is minus 1 del upon del z of x minus z, or plus this is 3y square plus k cap. This is k cap. This is del upon del x of this one. This is 3x square, and this is del upon del y. This is 0. Del upon del x of x cube plus yz. So this is 3x square minus of del upon del y of x minus z. So there is no term of y here. Okay. So this is so the curl of A is I cap minus I cap. This is 6xy plus y plus j cap 3y square minus 1 plus 3x square k cap. Okay, this is curl of A. So dot product of A will give, so dot product of this curl of A with k cap will give only 3x square. So the value of I is, let us take this as I. So the value of I is along the planar region S1, this is 3x square, and this is ds. ds we can write as dx dy. Okay, so our cone is like this. So this is our planar region. Okay, so the equation of this is x square plus y square is equal to 2a square. Okay, so we have the value of x as, let us take x as r cos theta, y is equal to r sin theta, and dx dy is equal to r dr d theta, and r varies from 0 to 2 and theta varies from 0 to 2 pi. So let us place the limit here for getting the desired result. So the value of I is equal to surface integral 3 times of x square is r square cos square theta into dx dy is r dr d theta. So r varies from r is equal to 0 to 2 and theta varies from theta is equal to 0 to 2 pi. So the value of I is equal to, this is 3 times of, this is r cube, r square, and this is r. So this is r cube dr, r4 upon 4, 3 times of r4 upon 4. This is 2, 0, limit is 0 to 2. And this is cos square theta d theta, limit is 0 to 2 pi. Okay, so this is, let us further simplify this. So I is equal to 3 times of, this is 2 to the power 4 upon 4 into this we can divide by 4 and multiply by 4. So this is 4 times of 0 say pi by 2 cos square theta d theta. This gets cancelled. So this is I is equal to 3 times of 16, and this is 2 into this we can write as half of pi by 2. Okay, so this 4, this gets cancelled with 4. So this is I is equal to 12 pi. Let us discuss question number 34, how we can solve this. So evaluate, we have to evaluate surface integral ax square plus by square plus cz square ds. Okay, and over the sphere, so the equation of a sphere is x square plus y square plus z square is equal to 1. So on comparing this with Gauss divergence theorem, so we have the Gauss divergence theorem as f dot n cap ds along the surface S is equal to divergence of f dv, triple integration. Okay, so something, this, on comparing this particular expression is this one. So we have ax square plus by square plus cz square must be something like f dot n cap ds. So we have ax square plus by square plus cz square is equal to f dot n cap, and ds is already there. So this we are getting on comparing this with this particular expression, that is f dot n cap into ds. Okay. So how we can find the value of n cap? So n cap is equal to del phi upon gradient of phi upon mod of gradient of phi. So this is our surface. So phi is equal to x square plus y square plus z square minus 1. So the gradient of phi will be I del upon del x plus j del upon del y plus k del upon del z of this is x square plus y square plus z square minus 1. So we have gradient of phi is equal to I times of del upon del x of this one, this is 2x, plus j times of del upon del y of this one, so this is 2y. Similarly for k cap, this is 2z, and del phi mod is equal to under root of this is 2x whole square plus 2y whole square plus 2z whole square. Okay, so we have the value of n cap as del phi upon del phi mod. So if we divide this one and this one, we will get the n cap as x I cap plus y j cap plus z k cap. So this is something is equal to f dot n cap. So this will be equal to f dot n cap is x I cap plus y j cap plus z k cap. Okay, so on comparing this, we will get the value of f as ax I cap plus by j cap plus cz k cap. Okay. So f dot n cap ds is equal to divergence of f dv. So let us find divergence of f. Divergence of f is del upon del x of ax plus del upon del y of by plus del upon del z of cz. So this is equal to a plus b plus c. This is divergence of f. Okay, so let us place the value here. So divergence of f is a plus b plus c. So let us further simplify this. Let us take this as I, and this f dot n cap ds is equal to this particular expression. So I is equal to triple integration divergence of f is a plus b plus c into dv. So this is equal to a plus b plus c into dv volume integral. So this is equal to a plus b plus c into v, and v is the volume of this sphere. So I is equal to a plus b plus c into 4 by 3 pi into radius ka cube. Radius is 1. So this is equal to I is equal to 4 pi by 3 a plus b plus c. The value of this expression is a plus b plus c upon 3 4 pi by 4 pi. This is the result. Okay, so we have discussed up to question number 34. So this is all about the Gauss divergence theorem. Thank you.